All right, so let's continue here with intercepts. Now, this is an effective way to plot functions besides using the table of values. But for right now, we just want to discuss, do we have intercepts? How do we describe them? Where do they occur? That sort of thing. So what is an intercept? Well, it's nothing more than where a function crosses an axis. And remember, we have two axes. We have the x-axis and the y-axis. So where we cross the x-axis is our x-intercept, and where we cross the y-axis is our y-intercept. Now, the x-intercept is going to be of the form x and 0 because it's on the axis, which means it has no y value. The y-intercept is going to be of the form 0, y, because it's on the y-axis and therefore has no x value. So let's look at this first example. Notice this is a line. A line is going to have two intercepts, or potentially just one, right? A vertical or horizontal line can have a single intercept. So for this one, I see we cross here and here. For the x-axis, this looks like it is 5 in the x direction, 0 in the y. That's our x-intercept. And over here, we have 0 in the x, 3 in the y, and that is our y-intercept. So again, this is actually a very effective way of graphing a line. It's not as nice when we get into other types of functions, but it's very quick for linear functions. All right, so let's take a look at another one. Okay, so here we have some function. We don't know what this is. Once you get more familiar with types of functions, you might recognize this as, it looks to be a cubic function. Right? It looks like it's something of the form y equals x cubed. Now, of course, it's shifted and moved around and that sort of thing. So the parent function is x cubed. But really, that's not of importance at the moment. We just want to know, does this thing cross an axis? And if so, where? Now, what I will point out is that we said that this is a cubic function. So it can potentially cross the x-axis 3 times. In our case, it's only going to do it twice, as you can see here and here. And it's going to cross the y-axis once, right there. Okay, so the x-intercepts, which we can have more of one, are going to be, that looks like for the first one, -1, 0. And the other one looks like 2, 0. Okay. And for the one on the y-axis, which we call the y-intercept, that looks to be like 0 in the x, 4 in the y. So it's just a matter of saying, where does it cross the axis, and can I name that point? And really it's, can I determine what's the value of x and what's the value of y? All right. I think we have one more here. Okay. So this looks to be like a parabola that's been turned on its side, which again, I can tell you that a parent function for this, there's a couple different ways to write it. It's going to be y equals plus and minus the square root of x, or you could technically write it as x squared equals y. I'm sorry, x equals y squared. Sorry. Again, not super important, but I'm trying to give you guys some other things to consider. And the reason for that I mentioned this is, again, we have a square That means we could potentially touch in two positions. Now, if this thing was turned around, for instance, right, then hopefully that would make sense. It would touch the y-axis in two spots. But it doesn't in this particular case. It actually has no y-intercept, right? It doesn't touch this axis at all. So there is no y-intercept, and we have a single x-intercept, which is at -4, 0. Okay. All right, so I think that concludes section 1.1. So let me know if you guys have any questions.